We would now take questions, and let's do it the same way. We collect some questions and then answer them one by one. So who would want to raise the point? Yes, Dr. Butt, and then Dr. Orachon, and then so far only two hands I can see.
Okay. So I don't have the actual question, but I just want for Professor Wang. Your result is very interesting. I'm thinking that probably I would like to see the relationship among the crops. Like probably you can do vector autoregressive models, like to analyze, because sometimes after you control for everything, there might be some residuals of something else that we cannot include in the model, and in that case we can use the that model, a VAR model, like to see the correlation among the share, because sometimes share of one crop increase that might correlate with the other crop. And the other things that came out in my mind just for the second presentation is that the seasonality. I think that's important because what you have done is seem to be, because you use the OLS, it's kind of like the mean regression model. So it's like if you can include, I'm not sure if the data allows, if you can do like a breakdown into the season, because in 1 year, some months you might want to plant something and the other months you want to plant something else. Okay, that's my question for Professor Wang. It's not a question actually. And for your presentation and the second presentation, I think it's very smart that your colleague used the threshold model, because like she got the right point, because the extreme events we need that kind of model, like a peak over threshold. But I would like to see if she can do a bit more, like okay, after she collects the data like that over the threshold, then analyze what is the effects of the of that kind of extreme weathers on the crop or something like that. Thank you.
Okay, we take Dr. Orachon.
My question goes to Dr. Pingali. I know it's your postdoc who's doing the analysis, but I just wonder, the results show that the duration of rains has more impact than the delay of the rains, but that might be so for high-yielding varieties, where the light is not, determining the timing of the plantation or planting, but not so for the land races or the traditional varieties that might require a certain period of time that you have to be planted. The other one is the intermittent rains. It's just not the number of days or amount of water, but also whether you have intermittent drought during the planting period.
Okay, do we have a third question? Yes, please.
Yes, my question to Professor Wang. Maybe I missed something. My question is pretty simple, because one of your conclusions mentioned that climate warming is beneficial to China. But you look at the share, rather look at the yield. Why don't you look at the yield?
Okay, Professor Wang, maybe you answer first, and then we... Yeah.
Okay, thank you for question. Yeah, for the first question is about our regression estimation method. In fact, it's not OLS. I have not indicated the methods. It is we use the seemingly unrelated regression. It's the one system of regression, so we can control some of the influence of other crops. And for the seasonal temperature and the precipitation, yeah, we included. I just deleted before presentation because considering the time limitation. I can show you after the meeting. We include. And also our variable in the model, not annual variable, it's growing seasons, each crops. So it's some shorter than annual. And for your question, in fact, this may be based on my understanding. Yeah, we have results on the impact of crop yield, and also similar to the India. estimate the impacts of climate change on the night crops yields based on the regression results, and also the data is based on in last 30 years. We have very good results on this. The reason I have not reported today because I thought the topic is the driver of structure change. I try to need to consistent to be the topic, so I just present. This is the new results for cropping structure. I think one of changing cropping structure. So, yeah, if you would like, I can show you our the impacts of yields. Yeah.
Okay, and then there was the other question.
Yeah, already answered.
Right.
Two
Okay,
questions.
yes,
Answered, yeah.
So, thank you for the comments. I shall convey them to Asha. Make sure she has a response to all of that in her paper. Just quickly, on the duration of rainfall and photoperiods, and this is a really important question, and which, if you look at one of the slides, we show the relationship between the rainfall length and in the non-irrigated environments and in the irrigated environments. And in the non-irrigated environments, you don't see much high-yielding variety use, modern high-yielding, so they're not photoperiod insensitive. And so some of the effect, that negative effect you're seeing there, may not be just irrigation, but it also could be this photoperiod sensitive. We haven't tried to tease that out, but that's a possibility that's where it's happening. It'll be worth checking on that some more. On the intermittent rainfall, it's hard to get that data. When you're looking over time at district level data, you can only get data on the onset and then on the total amount, but the intermittent has been hard to get, so it could be an issue there.
Okay, yes, okay, and there are more questions, next round, yes. Carl?
This is for Zheng Xia also. And it's not exactly about your paper, but it's sort of helping me to fill in my knowledge about what's going on in China and the impact of climate change. I remember a paper that this guy Ming Xu wrote on climate change a few years ago, where my understanding was that the effect of climate change was going to be that in the south there was going to be a lot more rainfall and more dramatic changes, whereas in the north it was going to be less rainfall in general because the way the monsoons have changed, and they weren't going to it was going to be stuck down in the south more or less. Is that still is there still a very different story in North China from South China? And I guess it would be wheat versus rice, right? I mean, the South China rainfall, greater rainfall and stuff would be in rice, and the impact in the north would be on the wheat. So there is that separation. I'm not sure what my question is. Sorry.
Okay. Seasonality.
I'm sorry, seasonality, yeah, and how and in terms of projections, what what people see for the future of South and North China.
Okay, Professor Wang.
Okay, it's true. The future change of climate, it's different by region. Of course, it will influence the crops very differently.
Mm-hmm.
Yeah, but in the future trend, the overall change trend for temperature can have the similar predict season.
Right.
Yeah, but for the rainfall, it's many different results. But the general result is still similar to what you mentioned. The future, the North China will become more dry, and the South China is more water. But some people think it's maybe not right. It's uncertainty. So if the prediction different, it means the influence of crop, yet will be also different. Yeah.
Okay, we have some contribution from Chikon.
Similar question is discussed.
You need to punch your.
Yeah. Okay. Yes. We published a paper a couple of years ago, review about nearly 100 papers on impact of rice weight made by major commodity. Roughly, we get about 49% of publication is positive, 51% our publication is positive. And I also talked to quite many people working climate change. Is if you get positive impact, it's hard to be published. So the positive impact paper published in lower impact factor journal and negative in. But in general, there are two conclusions. One is different by crop. Some crop is very negative, some crop is positive. Different by region. South China is a very big country. Normally, north part have more water and then they growing longer time period have positive. South have little negative. Then aggregate to whole country become very very small. I remember for rice weight it's about couple percent negative impact. So I was asked Mark earlier. Maize is 30% is quite a negative, quite big for China. But if globally maybe, but the point from this that we also published a few papers on impact. But again, it's quite inclusive, not very conclusive result. Right? We can publish positive impact, also can publish negative impact, depending on the journal editor which one they like. But by given the size of the country, I wouldn't say they're going to bigger impact. Based on our study and literature review, there are some by region, but at national level it's very small. First, second, we see the farmer already take a lot of adaptation measures, and the market price also can respond to these shocks. So at the end, we simulated by 2018, which Jinsha did not present here. By 2018, even under RCP 8.5 scenario, that is very big, or 8.5 scenario. RCP scenario, and the impact on agriculture is about 1% roughly. Yeah. And if under RCP is for lower RCP scenario, it's about 0.2, 0.3% negative on the average.
Again,
okay, it's the same.
Again, an example of large country effect. If the impact is randomly across the parts of the world, a country that's larger, the effect will cancel.
Okay. All right. Yes. Okay. One more question, and then Siddharth.
Short little one. I'm a frustrated policymaker, and after hearing these two papers, I don't know what's going on. Whether the climate change has increased or decreased my rice security, which way should we go? But I think there are a lot of information that are generated. My question really is there any way we can improve? Right now we are torturing a set of data to make it confess. And this set of data are coming from statistic and interview. I think it's not as scientific as it should be. There are a lot of errors when you go and do statistic, the interview and so forth, secondary data in particular. Is there any way that we can improve the quality of this type of work by using, for example, satellite data, analysis of satellite data? You know, we have fantastic detail of weather statistic, the temperatures, the precipitation, down to very specific areas. So we have very rich information there. So I think the gap there is on the crop side. So is there any way, this is from China and India, where we can really improve this set of information so we can have more precision on the answer
to the impact of this weather change. Thank you.
Okay, yeah. Who wants to? You want to comment or complement to that, Professor Zhang?
I want to add some information from nature science aspect. Our project data show in South China. Car is not here. In South China, in last 30 years, the technological progress like new seeds and better management technology bring the benefit be compensated by global warming in South China. But in North China, we got positive impact. Like in North China Plain, we have more time for winter wheat and maize rotation. Then we have a yield increase, and if you go even to northeast, northwest, the yield increase is much more significant because of warming and also more precipitation.
Okay. Professor Wang, you want to comment on that? Because, I mean, this issue that Dr. Sutat raised, this NASA database is available, and you can boil it down to, you want to say something?
Yeah, to point your question. I mentioned we reviewed nearly 100 papers. About 70, 80 papers come from science. They do the most sensing data, working 100 years or 50 years. So, and that's they really use science natural data. And the other, about 20 study based on the survey data, the statistical data. But interesting, come out results quite similar, positive, negative, and not a big.
Okay, thank you. Babu, you want to comment on that again? Or
I think Mark may know more about this than I would.
Mark, you want to comment on it?
Well, yeah, I mean, following on some of what Jikun and Jinsha said, I mean, there's been meta-analyses of all these things. In addition to your 100, there's a study of more than 1,000 articles on using crop models and impacts, and it's a very rich analysis that does. So it shows central tendencies. So tropical countries end up having more negative effects than temperate countries, and that's fairly systematic. They're not necessarily huge, but they are negative. And in country by country, again, you can get means and variances around those results. In general, on a global basis, there's also been some recent studies that we were involved in too, like future work and on looking at climate change impacts, where a lot of the best economic models were run with scenarios set up the same way, and they also end up showing in general central tendencies that are fairly small. Remember, I mentioned that 30% was a biophysical one. When we factor the biophysical effects into the impact model, the net effects are much smaller because once you shock maize, say, prices go up, you end up driving down demand somewhat, pushing up supplies, and you end up at an equilibrium point, maybe only be 5% lower, and that's what you get in economic models. So overall, most of the models are the central tendency ends up being small negatives, worse negatives in tropical countries. And I think one other thing just to mention is that people try to make a huge deal about climate change, but almost everything that is good to help adapt to climate change is also just plain good agricultural policies. So in a sense, it's just climate change makes it a little more costly and a little more difficult to reach the kind of goals you are. It's not transformational in terms of the kind of policies and investments that you want to make.
Okay, thank you. So I suggest that we close this part of the session. So thank you very much for presenters and the contributions.